In this problem, we're going to be working on a preliminary analysis of a collision. So first, let's read the problem to see what values we can work with. Suppose a small compact car with a mass of 1,000 kilograms. So we know our first value is 1,000 kilograms for the mass of this first car. And it's traveling at a speed of 15 meters per second. So now we know the velocity of the car. And it collides with a truck of a mass of 2,000 kilograms. So that's our second mass. And the truck is going at 10 meters per second. So there we have our second velocity. And as you can tell, this works as a vector. So here we can try to draw out the problem. We know that the car is going upwards and the truck is going towards the east. So we have a vector going northeast, and then we do know that this one's 2,000, just to keep in track. So it's 1,000, and the 1,000 is going 15 meters per second, while the 2,000 vehicle is going 10 meters per second. So now the first thing we're going to do is try to find the x and y components of both of these vehicles. So let's start off with the car. To get the momentum of the car in the x direction, of course, we're going to have to get the mass and the velocity in the x direction. So we know that the mass of the car is 1,000 kilograms, but then we also know that the velocity is not going anywhere in the x direction, since it's only moving northeast. So this is automatically 0, and the momentum of the car in the x direction is 0. So now let's try to do the momentum of the car in the y direction. And once again, we put the mass, but now we do have a velocity that we can plug in, so it's going to be 15. And we know that now the momentum in the y direction for the car is 1.5 times 10 to the 4th kilograms times meters per second. Now let's do the same thing for the truck. Let's go for the truck in the x direction. We know that the mass of the truck is 2,000 kilograms. And we know that the truck is going in the x direction at a speed of 10 meters per second. So we're going to end up with 2.0 times 10 to the 4th kilograms times meters per second. And then for the y direction for the truck, we know that it's going to end the same as what we got over here. We're going to end up with 0 again because it's not moving anywhere in the y direction, as you can see. So now that we have these values, we can try to work for the total momentum. So let me clear some space to work on the total momentum. Okay, so now we're going to add up both these values that are in the x direction and the y direction. Let's try to find the total momentum in the x direction. We know that the value for the car was 0, but for the truck the value was 2.0 times 10 to the 4th. And since this is just being added to 0, we know that this is our value. And then same things go for the momentum in the y direction of both vehicles. We know that for the car it was 1.5 times 10 to the 4th, and for the truck it was 0. So we're going to end up with this as our momentum in the y direction. So now the problem's asking us to find the magnitude. So to find the magnitude, we're going to have to use a Pythagorean theorem. So we can just quickly put in these values that we have, 2.0 times 10 to the 4th, and square it and add it onto our y value, the 1.5 times 10 to the 4th, and square it as well. And once you calculate this and plug it in the calculator, it's 2.5 times 10 to the 4th kilograms times meters per second. And this is our magnitude of the total momentum. Now we're also being asked here to find the direction, so let's move on to finding the direction, and we can work with the values that we got in the x and y direction. To find the direction, we can do the tangent of theta, and that would be our y value over our x value. So we have 1.5 times 10 to the 4th, and we have 2.0 times 10 to the fourth, and they both have the same units. We have kilograms times meters per second, kilograms times meters per second. So these units are actually going to cancel out, and we're going to be left, when we plug this in, we're left with 3/4. But this does not give us our angle yet. We're going to do the inverse tangent of 3/4. And this will actually give us our final angle, which is 36.9 degrees. And we know that it's northeast.